NASA officials reveal they have decoded transmissions from 3I Atlas. What it says might change everything.
NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new.
The James Webb Space Telescope has once again shifted the course of human understanding, not by peering into the distant dawn of the cosmos, but by turning its attention much closer to home. Astronomers have confirmed that the interstellar object known as 3I/Atlas, an enigmatic visitor from beyond our solar system, is now on a trajectory that leads directly toward Mars. The confirmation, made possible through Webb's unparalleled infrared sensitivity and orbital precision, has electrified the scientific community and ignited intense discussions about what this means for planetary science, interstellar studies, and the fragile architecture of our solar system. Before we start, smash the like and subscribe buttons for more updates. 3I/Atlas first appeared as a faint and almost unremarkable point of light in early surveys, but its velocity and orbital inclination quickly gave it away as no ordinary comet. Like Oumuamua before it and Borisov after, 3I/Atlas originated from deep interstellar space, carrying with it the mysteries of a region no probe or telescope has ever truly explored. What sets this discovery apart from all other interstellar objects so far is not just its size and composition, but its confirmed path, a collision course with Mars that will unfold within a time span that astronomers can observe with exceptional clarity. Webb's instruments locked onto the object, analyzing its heat signature, volatile outgassing, and structure. And with those measurements came the realization that its trajectory was not merely a close pass. This time, a planet is directly in its path. The implications of such a trajectory are staggering. Mars has long been a focal point of planetary science, a potential cradle for microbial life in its ancient past and a future destination for human exploration. Now it faces a cosmic rendezvous unlike any in recorded history. A collision with an interstellar object carries consequences beyond a mere planetary impact. The material that 3I/Atlas carries is alien to our solar system, formed in the accretion disks of another star, shaped by a history of chemistry and radiation unlike anything Earth or Mars has known. Should it strike the Martian surface, it will quite literally seed the planet with the matter of another star system. Scientists are now considering the profound ramifications, the mixing of interstellar and Martian material, the geological scars it will carve into the planet's surface, and the clues it will leave about cosmic formation on scales both intimate and vast. Astronomers tracking the object note that 3I/Atlas is larger than both of its famous predecessors, measuring several kilometers in diameter. Such a body colliding with Mars would unleash energy equivalent to some of the most cataclysmic events in planetary history. The craters it would form could rival or even surpass those left behind by the great impacts in Mars's distant past. Unlike Earth, Mars lacks plate tectonics and dense atmospheric processes that erode away evidence of ancient collisions, meaning that the scar left by 3I/Atlas will remain etched into its face for millions of years. Future explorers, robotic or human, would find in it not just a monument to planetary violence, but a layered record of an object born around another star and delivered violently onto Martian soil. The Webb telescope's role in this discovery underscores the power of modern astronomy to look not just far, but precisely. Its infrared instruments captured the faint glow of sublimating gases and dust streaming from 3I/Atlas as it was warmed by the sun. By mapping those emissions and their distribution, astronomers could model the object's shape and spin and, most critically, refine its orbit. It was this refinement that erased ambiguity. There would be no near miss. The orbital arcs converged on a single conclusion: impact. In an era where astronomical discoveries often deal in billions of light years and incomprehensible scales, the immediacy of an interstellar object striking a neighboring planet has created an event that feels both cosmic and tangible. Planetary scientists are already preparing for what this means in terms of observation campaigns. Mars, with its armada of orbiters and surface rovers, is one of the most intensely studied bodies in the solar system. Every instrument trained on it, whether in orbit or on the surface, will now be poised to capture unprecedented data from this impact. The opportunity is singular: to witness in real time the collision of a body forged outside our solar system with a terrestrial planet. For decades, scientists have theorized about panspermia, the idea that life's ingredients can travel between worlds or even between stars on rocky fragments. With 3I/Atlas, those theories may move from speculation into observable reality, as interstellar compounds are deposited into Martian regolith, potentially mixing with ancient organic signatures already locked in its rocks. The psychological weight of the discovery cannot be understated either. Humanity has long looked at impacts through the lens of Earth's own history. The cataclysms that wiped out dinosaurs, the craters that pockmark our moon. To see another world become the target of an interstellar strike forces us to confront our own vulnerability. If 3I/Atlas had shifted just slightly, the trajectory could have led here, to Earth. Mars becomes, in this instance, a proxy for our own planet, a reminder of the precariousness of celestial mechanics, yet it also becomes a laboratory, sparing us the consequences but gifting us the knowledge. Speculation about the object's composition is already generating heated debate. Early infrared spectra from Webb reveal unusual chemical signatures not entirely consistent with typical solar system comets. There are indications of exotic carbon chains, silicate blends altered by different stellar chemistries, and volatiles that suggest formation in a colder, darker environment than our Kuiper belt. These markers tell astronomers that 3I/Atlas likely originated in the outer reaches of another star system, a fragment cast off during planetary formation or perturbed by gravitational interactions before it was set adrift into interstellar space. For billions of years it wandered the void only to find itself now locked onto Mars. That journey and the final destination make it an unprecedented scientific treasure, one that will rewrite textbooks even as it pulverizes Martian rock. Mars itself is no stranger to violent collisions. Its surface testifies to a history of bombardments, from the colossal Hellas Basin to the stark cliffs of Valles Marineris, whose very formation may have been influenced by ancient impacts. Yet never before has humanity been able to watch such an event unfold live. The armada of instruments already circling Mars means that every stage of the impact can be observed. The approach, the atmospheric entry, the explosive release of energy, and the settling of dust across Martian plains. Each phase holds secrets about both the interstellar object and the planet it collides with, and scientists are already drafting plans to synchronize their observations, ensuring that no detail is lost to the vastness of space. The cultural resonance of this confirmation is profound as well. Humanity's imagination has long been filled with stories of celestial objects colliding with worlds, mythologies of fire from the sky, literary visions of cosmic disaster, and cinematic depictions of planetary doom. Now, for the first time, we are certain of such an event on a neighboring planet, not as fiction but as fact. It is a reminder that the universe is not static, that it is a dynamic stage where colossal events unfold whether or not we are watching. And this time, we will be watching, with cameras, sensors, telescopes, and perhaps even with the first human explorers preparing for a future journey to the Red Planet. The very nature of 3I/Atlas being interstellar transforms the narrative. Ordinary comets and asteroids belong to our solar system, their orbits and histories tied to our sun's gravitational dominion. 3I/Atlas is an outsider, carrying the fingerprints of alien chemistry and the echoes of distant stellar processes. Its collision with Mars is not just a planetary event, but an interstellar one. For the first time, matter from one star system will collide in plain sight with the surface of a terrestrial planet in another system. The significance stretches beyond astronomy into philosophy, biology, and even questions of cosmic destiny. Are such events common? A hidden mechanism of mixing star systems and spreading complex chemistry through the galaxy? Or is this a rare occurrence, a chance alignment that we are privileged to witness? Scientists are also grappling with the time frame of the impact. Webb's data allow precise orbital modeling, and though the countdown is measured in years rather than months, the inevitability of the collision is beyond doubt. This gives ample time for preparations, for planning coordinated campaigns across telescopes on Earth and in space, and for ensuring that every instrument on and around Mars is operational to record the event. It also provides an unusual sense of anticipation, a cosmic countdown visible to the entire world, a reminder of our interconnectedness as a species watching a celestial drama unfold on a stage next door. There are already discussions about potential missions that could be launched in the window before impact. Concepts are circulating about probes that could intercept 3I/Atlas en route, analyzing it directly before it reaches Mars. Others imagine impact monitoring satellites placed in Martian orbit, dedicated to capturing the event in unparalleled detail. Such missions would require unprecedented coordination and rapid deployment, but the scientific payoff would be immeasurable. To touch an interstellar object, to study it in situ, and then to watch its collision with a planet, this would be a first in the history of exploration, the kind of endeavor that defines eras of scientific progress. The sheer energy of the impending collision has sparked questions about Mars's environment and atmosphere as well. While the planet's thin atmosphere offers little resistance, the impact will still release enough force to throw debris high above the surface, perhaps even into temporary orbit. Dust and ejecta could alter atmospheric dynamics for years, providing a living experiment in planetary climate and geological processes. Mars, already a planet of fascination for its ancient rivers, its icy poles, and its whisper of methane, will become even more enigmatic after the interstellar strike reshapes part of its surface and sky. Beyond the immediate science, the event reawakens an awareness of the vastness of interstellar space and the wayward travelers it can send across our path. 3. I/Atlas is not the first, and it will not be the last. With Webb and other next-generation observatories, humanity will detect more such interstellar visitors. The knowledge that one of them is now fated to collide with a neighboring planet sharpens our curiosity about the rest. What other objects drift between stars? What other secrets do they carry? And what role might they play in the story of life and planetary evolution across the galaxy? The countdown to impact is not just astronomical, but deeply human. Schools, research centers, and public observatories will follow its progress, tracing its arc across the sky as it draws ever closer to its Martian target. Artists and writers will find inspiration in the idea of a visitor from another star meeting its end on the red planet. Scientists will prepare, calibrating instruments and refining models. And all the while, the James Webb Space Telescope will continue to watch, its golden mirrors reflecting both the past light of the cosmos and the imminent drama of a celestial collision. Mars, a world that has always invited comparisons to Earth and fueled dreams of exploration, is about to undergo a transformation visible across the solar system. When 3I/Atlas finally meets the Martian surface, it will not be the end of its story, but the beginning of countless new ones. Its impact will carve a crater, scatter interstellar dust, ignite shockwaves in thin Martian air, and fuse the destinies of two worlds separated by light years of origin. Humanity, with eyes now sharper than ever thanks to Webb, will bear witness, not as passive observers, but as participants in the unfolding history of the cosmos. For in seeing it happen, in recording and studying and remembering, we join the narrative of a universe that never ceases to move, collide, and astonish. The moment the Webb telescope confirmed 3I/Atlas was on a collision course with Mars, the entire narrative of interstellar research expanded into an entirely new dimension. What had once been speculation about interstellar objects passing through our solar system has now become the reality of direct interaction, not just with the sun's gravity, but with a planetary surface. This shift creates new frontiers for how astronomers, planetary scientists, and even philosophers think about our place in the cosmos. The excitement does not rest simply on the fact that an alien body will strike Mars, but on the possibilities that such an event opens for science, exploration, and the understanding of universal processes that transcend one star system. At its heart, the significance lies in the fact that Mars will act as a canvas for interstellar material to imprint itself physically and chemically. Mars, unlike Earth, has no thick oceans or tectonic cycles to erase geological records. The scars and deposits from 3I/Atlas will remain visible and analyzable for millennia. That permanence turns Mars into a kind of cosmic archive where the evidence of interstellar material can be studied long after the impact. This transforms the planet into a repository not just of its own history, but of galactic history, storing records of alien chemistry on its dusty plains. The object's interstellar origin also forces scientists to reconsider assumptions about how common such events might be. Until recently, the detection of interstellar bodies was regarded as extraordinary, a once-in-a-century event. With 3I/Atlas, however, the growing realization is that the galaxy is teeming with such wanderers, and our instruments are finally capable of spotting them. That one of them has lined up for impact on Mars suggests that these collisions may occur far more often in the broader sweep of time, perhaps shaping planetary evolution throughout the Milky Way. Entire planets may carry geological signatures of interstellar collisions, just as Mars soon will. The collision could even offer insights into why certain planets develop chemical conditions favorable to life, while others remain barren. Beyond the scientific questions, the event reshapes the way exploration missions to Mars will be planned in the future. Human settlement efforts, robotic expeditions, and resource mapping will all be influenced by the knowledge that a massive interstellar object has altered the Martian landscape. Future colonists will one day walk near the impact site, knowing they are treading on ground mixed with the material of another star system. For them, it will not just be science, but a lived experience, a connection between the human presence on Mars and the galaxy beyond. This collision, though destructive, provides the first direct link between humanity's expansion into the solar system and the larger narrative of interstellar exchange. From a technical perspective, Webb's detection demonstrates just how crucial infrared astronomy is in identifying and tracking such objects. Traditional optical telescopes often struggle with faint and fast-moving bodies, but Webb's infrared capabilities allow it to detect the heat emitted from sublimating ices and even faint surface heating. That sensitivity turned 3I/Atlas from an anonymous speck into a well-characterized object with a defined trajectory. In doing so, Webb has not only confirmed the impact, but has also given humanity one of the most precise opportunities ever to study an interstellar object. Every piece of information about its spin, surface irregularities, and chemical composition deepens the profile of a body that carries the history of another solar system embedded in its core. There is also a profound cosmochemical aspect to consider. When 3I/Atlas collides with Mars, its material will be shocked, vaporized, and redistributed. Some compounds will break apart under the intense heat of impact, but others will fuse into new structures. The chemistry unleashed in that moment will create entirely novel compounds that may never have existed before in either system. Scientists anticipate that Mars could become a natural laboratory where the chemistry of two star systems mixes violently, producing outcomes that could teach us about the raw creative processes of the universe. To capture and analyze this chemistry is to glimpse not just what makes life possible, but how matter itself evolves under conditions that mimic the violent early years of planetary formation. The scale of the collision also makes this one of the most significant planetary events humanity will ever witness firsthand. Although Mars is a smaller planet with a thinner atmosphere, the impact of a body several kilometers wide will rival or exceed the largest impacts in its modern history. The shock waves will travel across the crust, potentially triggering secondary seismic activity measurable by instruments already operating on the Martian surface. The InSight lander, though aging, could potentially pick up precursor seismic signatures before shutting down completely. Other landers and orbiters will provide complementary data sets, creating a multi-instrument symphony of observations that allow humanity to dissect the anatomy of a planetary collision in unparalleled detail. The potential for ejecta escaping Mars adds yet another layer of fascination. Although Mars's gravity is weaker than Earth's, the collision may hurl fragments into space, some of which could eventually travel toward Earth. While small in scale, such fragments would represent interstellar Martian hybrids, rock born of another system, collided with Mars, and then flung across interplanetary space. Should any of those fragments be captured and studied, it would be the ultimate cosmic delivery system, a gift from two worlds meeting violently and scattering their remains into the solar system. The possibility alone has sparked interest in developing capture strategies for small meteoroids and micrometeorites following the event. At the cultural level, the anticipation of 3I/Atlas's impact reshapes how humanity envisions Mars. No longer is it simply the red planet of myth and exploration, but now it becomes the stage for a galactic drama. The collision elevates Mars from a planetary neighbor to a participant in a cosmic process, its landscape chosen by chance to receive the material of another world. This sense of drama inspires awe, reminding humanity of the interconnectedness of the universe. It speaks to the randomness and inevitability of celestial mechanics, where orbits can align in such a way that entire star systems collide in miniature upon a distant planet's surface. Another dimension is the planetary protection angle. Although no life has been confirmed on Mars, the introduction of alien material from another star system could complicate the search for indigenous biosignatures. Future missions will need to carefully distinguish between organic material deposited by the impact and any native Martian signatures. This could create scientific challenges but also extraordinary opportunities, as the interstellar object may carry prebiotic molecules or complex organics that show how chemistry evolves in environments outside the Sun's reach. The mixing of such material with Martian soil creates a naturally occurring experiment in astrobiology on a planetary scale, one that will be studied for centuries to come. The philosophical implications ripple outward as well. Humanity has often imagined itself as isolated within a single solar system, with stars as distant, untouchable points of light. The collision of 3I/Atlas with Mars collapses that isolation, showing that the stars do not remain separate but sometimes send their fragments across gulfs of space to collide with neighboring worlds. In a sense, the galaxy is more interconnected than we imagined, with matter migrating between systems in ways that can influence planetary histories and potentially even the spread of life. It reinforces the idea that no world is truly isolated, and that the boundaries of solar systems are porous, blending into the larger fabric of the galaxy. Looking at the event through the lens of cosmic history, one can imagine similar collisions occurring on Earth in its ancient past, seeding our planet with exotic material that may have helped catalyze the chemistry of life. If 3I/Atlas is rich in organics, and if fragments of such objects have struck Earth before, then our own existence may be partly interstellar in origin. Mars, by receiving such an object in recorded history, gives humanity a chance to witness firsthand what may once have shaped Earth itself. The observational data collected will inform models of early planetary chemistry, impact dynamics, and the broader role of interstellar bodies in planetary evolution across the galaxy. The political and social dimensions of the event are also worth noting. Space agencies around the world are mobilizing their resources to prepare observation campaigns, and the collaboration required is unprecedented. The impact is not owned by any one nation or agency, but is a shared cosmic event that the entire world can study. This creates an environment of international cooperation, where scientific rivalries give way to a recognition of shared opportunity. The spectacle of an interstellar collision uniting humanity in collective observation becomes a reminder of how exploration can transcend borders and divisions. It becomes a global project in every sense of the word. The countdown to the collision also has a unique psychological effect. Unlike other celestial events, this is not simply a predictable eclipse or a distant supernova whose light happens to reach us. It is an unfolding event with a clear trajectory and a known outcome. Humanity will live with the knowledge of its inevitability, tracking 3I/Atlas as it approaches Mars day by day, year by year. This sense of anticipation, the certainty of impact, transforms astronomy into something immediate and almost visceral. People will follow its progress not as passive observers, but as engaged participants, aware that they are witnessing history on both planetary and galactic scales. From an engineering perspective, the event also stimulates innovation. Concepts for monitoring satellites, impact analysis probes, and data relay systems are already being brainstormed, with the aim of maximizing the scientific harvest. These efforts push technology forward, as the demand for rapid deployment and high-precision observation forces new advancements in propulsion, imaging, and data handling. In this way, the collision indirectly accelerates human capability, driving innovations that will serve future exploration not just of Mars, but of the outer planets and eventually interstellar space itself. At a more poetic level, the story of 3I/Atlas is one of cosmic wandering and sudden destiny. For eons, the object drifted between the stars, anonymous and unobserved, carrying within it the frozen history of another system. Its journey was silent, its trajectory unknowable, until gravitational forces bent it into our solar system and Webb's golden mirrors revealed its presence. Now, instead of drifting indefinitely, its story will end in fire and collision on the red sands of Mars. There is something profoundly human in that narrative, a reminder of how even the most distant wanderer can find its fate in unexpected ways. As the object nears, new phenomena will unfold that extend beyond the impact itself. Its coma and tail will evolve as it approaches the Sun, providing astronomers with opportunities to study interstellar volatiles under solar heating. Unlike solar system comets, its outgassing may follow unfamiliar patterns, with compounds releasing at different thresholds and producing spectral lines never before seen. These emissions will act as a preview, a chemical fingerprint of the alien matter that will later collide with Mars. The data collected during this approach phase will be as important as the impact itself, offering a complete picture of the object's behavior and structure. The implications for education and public engagement are equally vast. Planetariums, classrooms, and observatories will weave the story of 3I/Atlas into curricula, inspiring the next generation of scientists, engineers, and explorers. For young students, the idea that they are alive at the time of an interstellar collision with Mars may shape their career paths, their curiosity, and their worldview. It becomes a story that transcends the scientific journals and enters into human culture, a reminder of how cosmic events can inspire creativity and ambition far beyond the realm of astronomy. Even the arts will absorb the event. Writers will craft narratives, painters will capture the imagined brilliance of the collision, musicians will score symphonies inspired by the crash of worlds. The blending of science and imagination around 3I/Atlas ensures that it will not only be studied but remembered, not only measured but felt. It becomes part of the mythology of our time, a symbol of humanity's expanding vision of the universe and our ability to watch the cosmos unfold with clarity and wonder. As the countdown continues, Webb will remain the sentinel, its golden mirrors turned toward the object that will forever change our perception of interstellar wanderers. Other telescopes, both ground-based and orbital, will join the vigil. Together, they will weave a tapestry of observation that captures every nuance of 3I/Atlas's journey, from the faint shimmer of its coma to the moment its core meets Martian soil. Humanity will not miss a single step of the story, ensuring that this collision becomes the most documented planetary event in history. When astronomers confirmed that 3I/Atlas was destined for Mars, the conversation quickly shifted to the deeper layers of what this means for planetary evolution and the scientific narratives we build about cosmic history. For centuries, humanity has studied craters across planets and moons, treating them as evidence of violent epochs that shaped the solar system. Yet those were impacts by local debris, asteroids and comets born under the same sun. This is different. For the first time, scientists will be able to watch another planet absorb material that was born under a different star, carrying chemical imprints from a place we have never visited. This single event becomes a living experiment in cross-stellar interaction, with implications reaching into nearly every branch of space science. Astrobiology stands to gain perhaps the most. Mars has been a puzzle, with its hints of ancient rivers, underground ice, and traces of methane suggesting the possibility of past or even dormant life. When 3I/Atlas collides, its cargo of interstellar compounds will join the Martian chemical environment. If complex organics or prebiotic molecules are present in the impactor, they will interact with Martian soil and atmosphere in ways we can study directly. Scientists often speculate about panspermia, the idea that life's building blocks spread across the cosmos via cosmic collisions. The impact of 3I/Atlas will create a natural testbed for that theory. Researchers will be able to ask whether interstellar organics can survive the violence of impact, whether they can persist in a planetary environment afterward, and whether they could meaningfully alter the chemistry of a world already rich in its own geological and atmospheric complexity. The observational networks that will be mobilized for the event are unprecedented. Earth-based telescopes will monitor the approach, charting the evolution of 3I/Atlas as it nears the Sun. Orbital assets around Mars, such as the Mars Reconnaissance Orbiter and the ExoMars Trace Gas Orbiter, will record the collision and aftermath from above. Surface rovers like Perseverance and Curiosity, even if not directly positioned to view the event, will analyze atmospheric dust and seismic waves propagating through the crust. Together, these instruments create a layered approach to observation, providing data from multiple vantage points. For the first time, humanity will not just watch a planetary impact, but record it comprehensively, from orbit to surface to global atmospheric response. The scale of the impact brings into focus another dimension: climate alteration. Mars's thin atmosphere is vulnerable to disruption. A collision by an object of several kilometers in diameter will loft fine dust into the sky, potentially shading large regions of the planet for years. While Mars lacks the complexity of Earth's climate systems, such a dust veil could lower surface temperatures, alter wind patterns, and even affect the stability of surface ice. For scientists studying Martian climate dynamics, this event is a natural experiment in atmospheric forcing. It will provide insights not only into how Mars reacts to sudden perturbations, but also into how ancient events of similar scale may have shaped its long-term climate evolution. From the perspective of planetary defense, 3I/Atlas is a wake-up call. Though Earth is not the target, the fact that a large interstellar body can intersect a planet's orbit with such precision emphasizes the importance of monitoring deep space. Current planetary defense efforts focus primarily on near-Earth objects, cataloging asteroids and comets that orbit within our solar system. Interstellar objects, however, do not obey predictable orbital cycles. They arrive suddenly, their paths shaped by unknown origins, and their velocities far greater than most local bodies. The impending collision with Mars demonstrates that these visitors are not just transient curiosities, but real agents of planetary change. It underscores the urgency of developing detection networks sensitive enough to spot them well before they approach, and strategies to assess their risks to Earth. One of the most intriguing aspects is how the Martian surface itself will preserve the record of this event. Unlike Earth, which erases craters through erosion and tectonics, Mars' lack of active geology ensures that the scar from 3I/Atlas will endure. That means future generations, even centuries from now, will be able to study the impact site with fresh tools. Human settlers could one day establish research outposts along its rim, analyzing layers of fused rock and interstellar dust. For them, the site will be both a scientific treasure and a symbolic landmark, a place where two star systems met in a single, violent instant. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on 3I/Atlas colliding with Mars in future? We want to hear from you. Thank you for watching and see you next time.